Okay, this is example 2 of areas on the curves and lines. Now, you're being told here that the region R is bounded by the curve y equals x squared plus 2. There's the curve. Bounded means, of course, that it's an enclosed area. So it's bounded by the curve. The x-axis and y-axis, well, there's the bottom boundary. And there's the y-axis boundary there. And the line that joins the points 2, 6, 2, 26, 0. So it's bounded by that line, that line, that line, and this line. You've got to find its area. Well, when you see a thing like this with a straight line, always ask yourself, how can I split this up into two shapes? And the way, of course, you can do this, if you look carefully, is you can split it up into a triangle, which I've called Q, and an area underneath the curve, which I've called P. So clearly the area that they want you to find, R, is the sum of those two areas, P and Q. All right, well, how do we do that? Well, clearly, if we integrate this curve, x squared plus 2, between the limits of 0 and 2, we'll get the area P, which is that thing there, which I've labeled area P there. And this one, a triangle, is a half the base times the perpendicular height. Well, the perpendicular height is clearly the 6, the y coordinate of that point there, which is 6. And this base is 26 minus this 2, which is going to be 24. So this half makes the 6, or divides into this 2, divides into the 6, 3 times. This is 24. 3 times 24 is 72. And there we have it. Okay, we've got this plus 72. When we integrate this, we get x cubed over 3 plus 2x. We now put in the limits and work this out. So the limits are the following. We're putting in 2 for the x, so it's 2 cubed, and there 2 times 2 there. Of course, when we put in the limit 0 into all of this, that goes to 0, this goes to 0, the whole thing is minus 0. And I've just written it in just to show you that it does disappear. This is 2 times 2, which is 4. This is 8 over 3, which is 2 2/3. Add them all up, you get 78 2/3 units. Okay, so that's the way you would do that as your area for R. Okay, let's go on to example 3. Where is it? There we go. Let's zoom in and do this one. Okay. Right. Now, we are again finding the area underneath the curve, and the curve is given by this x plus 1 all squared plus 1. If you multiply out the brackets, you get a quadratic looking like that. So you've got to integrate between minus 2 and 1. If you do that, you get this. So we're going to be getting x cubed over 3 for the first term's integration. For the second one, it's going to go 2x squared over 2. And of course, those 2's are going to cancel. And this 2 on the end is going to go to 2x between the limits of minus 2 and 1. Now, when I've shown this to students, they have always, not always, but quite often, they mess up this part here because they're substituting in a negative limit, and they don't take care of the signs. And if you don't take care of the signs, it's a recipe for disaster. All right, so let's see what we do. We substitute first the upper limit 1 into there and there and there, and there it is here. That's 1 cubed is 1, 1 squared is 1, and 2 times 1 is 2. However, we must be super careful with the signs. It's minus, make a brackets. Now this minus 2 is going in place of the x cubed there, so it's minus 2 cubed. Now because it's an odd cube, an odd power here, when we multiply this, it's going to come out still negative, as negative 8 over 3. Okay, if I move down, you'll see there it is, negative 8 over 3. Of course, when this is an even power, and we raise minus 2 to an even power, even 2, it's going to go to plus. So this is plus 4. However, this minus 2 here is going to go with this plus 2 to negative 4. And negative 4 plus 4 are going to disappear because they just cancel each other out. So your final question, your final calculation is that you've got 2 plus 1 is 3, and 3 plus a third is 3 and a third. Now 3 and a third is really 10 over 3. Okay, 3 threes are 9, plus 1 is 10. So you're adding 10 thirds to 8 thirds, and that gives you 18 thirds, and 18 thirds is 6 units squared. So that's how you do that one. Okay, now let's go on to the final example, and then we're done. Okay. Oh dear, I'm silly, it was on the bottom of the other page. Yes, it's this one here. Sorry, I thought we had come to the bottom of the page with 6 units squared. Whoa. Okay. All right, so the next example, which I gave my students, was this one here. Okay, it says the region R, here it is bounded by the curve y equals e to the power of minus 3x. Well, there it is, that's that curve there. And the lines x equals minus 2, x equals 3, and y equals minus 4, like that. Now again, you should really be saying to yourself, hang on a minute, I've got 2 areas to find here. I've got a rectangle there, and I've got an area under the curve there. And that's exactly what we do. So we now go to the calculation. I'll show you how that works, what it looks like. Here it is. Let's zoom in so we can follow this carefully. There we are. All right, so the area R is the area under the curve from x equals minus 2 to x equals 3, plus the area of the rectangle. Well, the area of the rectangle, if you look at it, is 5 along the horizontal, and it's 4 units down. Now, because it's below the x-axis, it would normally be counted as a negative area. So I am going to put these little lines there and there because I want the absolute value. I want the positive value, in other words. So that's going to be, that rectangle is going to be a 20 units, square units added on. All right, let's look at this thing. This is the real nuts of this problem here. We are now going to integrate e to the minus 3x between the limits of minus 2 and 3. Now, this is the little maneuver we're going to do here. We let u equal minus 3x, okay? And so if I differentiate that, I get du by dx is equal to minus 3. So when I cross multiply the dx, I can see that du is equal to minus 3 dx. So if I pre-multiply the dx by minus 3 to make all of that into du, I've got to divide by minus 3 at the same time. So that minus 3 I can put in front of the integral sign in the form of 1/3. There it is, or minus 1/3. Okay, there. Now I can integrate eu du. Don't forget this minus 3x is now u. But because we've changed the variable into u, we cannot write minus 2 and 3 as our limits. Just write u1 and u2. Okay? Now, when we integrate eu, we get eu. Okay? So we've got e to the minus 3x coming out. And now we've got our limits, minus 2 and 3, to substitute in. You will notice that I put these squiggly brackets here because this minus 1/3 is going to multiply everything that happens when we do the substitution of the limits. You'll see that here. There it is. There's this minus 1/3. And now I'm substituting in 3 for the x there, being very careful with brackets. Okay, the reason is when I substitute the minus 2 into there, I must use brackets because that minus 2 there is going to multiply this minus 3 to give positive 6. This is going to give me e to the minus 9. Okay, so when I do that, that's what happens. I get e to the power of minus 9, take away e to the power of positive 6, and all that comes to, it's multiplied by this minus 1/3. And when I do that, I get this brackets becomes this minus 403 point blah blah blah, and that minus 403 is going to make is going to multiply with this minus 1/3 to become positive. And when we add the 20, we get a final answer of 154.48 units squared to 2 decimal places. Okay, so I hope that's given you a little bit more of an example. Okay, thank you very much.